of kilometres. But what we're looking at is just a tiny part of something much, much bigger. This is the edge of a gigantic slab of the Earth's crust which runs unbroken for 7,000 kilometres. Right from this point, under the Atlantic, across the USA, all the way to California. It's what's known as the North American Plate. The Earth's surface is broken up into 7 major chunks called plates. They're so enormous that they can carry an entire continent and extend far under the sea. Strip away the Atlantic Ocean and you can see a long boundary between 2 of these plates that runs along the ocean floor until it rises above the waves, cuts through Iceland, to eventually join up with the rock face at Thingvellir. It's possible to see this plate boundary from a completely different perspective. This is a very cold place to go scuba diving. The water's just 4 degrees Celsius. But it's worth it. Because I'm actually swimming in the gap between the 2 giant plates that run through Iceland. To my left, the North American Plate, and to my right, Europe. These sheer rock faces were once joined together, but driven by immense geological forces, the land was split apart to create these deep chasms which filled with water. It's hard to imagine a force that can move continents apart. Yet this is precisely what the Earth's inner heat is able to do. It happens because hot rock rises, heated by the Earth's core. Near the surface, the rock spreads in 2 directions and goes sideways. It begins to lose heat. Eventually, the much cooler rock sinks back down. Through this spreading process, the Earth's crust is very slowly dragged apart. And it's this that ultimately causes the continents to move. The lava lake at Ertali is an example of the same process, but in miniature. As we've seen, the movement of hot lava drags the crust across the surface of the lake, just as the continents are pulled across the Earth's surface. To appreciate the idea of continents moving, you have to step outside human timescales and think in terms of a completely different time frame. The continents here are drifting apart at 2 centimetres every year. In my lifetime, we're talking just a couple of steps. Even in 1,000 years, that's just 20 metres. It's only when you start to think in terms of millions of years that you realise just what can happen. $225 million years ago, our planet looked very different. All the continents were joined together in a single supercontinent called Pangaea. As the plates moved, this supercontinent broke up. New oceans formed as continents drifted around the globe. It's this that has created the shape of the world we know today. But the plates never stop moving. In the distant future, our continents will once again be reunited in a new giant supercontinent. We've seen what happens when the plates move apart. But when they crash into one another, the effects are even more dramatic. The collision of the Earth's plates is responsible for the most spectacular mountain ranges on our planet. To see how they're created, I've come to New Zealand's South Island. These stunning peaks run 500 kilometres along the west coast, forming a dramatic spine down the island. According to Maori legend, these mountains are made of the petrified bodies of 4 gods who got stranded here on a canoeing trip to Earth. As they were attempting to return to the heavens, a big storm blew up and capsized the canoe. They climbed on board and waited for someone to rescue them, but no one came. As time passed, they slowly turned to stone. As far as geology goes, there's a slightly different explanation. It may not be as romantic as Maori legend, but it's every bit as epic. What was to become New Zealand was once a group of scattered islands. The collision of the Pacific and Australian plates forced these islands together, creating the familiar outline of New Zealand that we know today. Along the collision zone, the land was buckled and a line of mountains rose up. New Zealand's mountains are around 5 million years old. That may sound ancient, but it's just a geological blink of an eye. Yet even in this short time scale, these peaks have grown into giants. All the world's great mountain ranges form in this way when continents collide. You can really get a sense of how the surface of the Earth crumples when you look down from space. These are the European Alps, the South American Andes, and the Himalayas of Central Asia. They're all relatively young, born out of recent collisions between plates. Sometimes you can actually see their growing pains. Earthquakes are a horrific force of destruction. Entire cities can be wiped out at terrible human cost. But this is what happens when our planet builds its great mountain ranges. In October 2005, a devastating earthquake hit the western Himalayas in northern Pakistan. The area around the town of Muzaffarabad was completely razed to the ground. But satellites measuring the height of the surrounding land before and after the earthquake revealed that something else had happened as well. The red and yellow colours show how the hills to the east of the earthquake's epicentre had actually risen as much as 5 metres during the earthquake. This process, repeated thousands of times, has helped build the Himalayas into the greatest mountain range on Earth. And it's just as well that the Earth's inner heat continues to push